go over all of them.
Okay, so we'll just go over all of them. Okay, so for the first question, let's see. 1 sec, sorry. Okay, let f of x and g of x be functions such that that stuff. Which of the following claims must be true? Check all that apply. So you see the limits, and then does everyone recognize that it's a limit definition of the derivative?
Yeah.
Okay, so you know that f prime of 0 is equal to 5, and then f prime, or g prime of 0 is equal to 7. So look at the first choice, and then you can cancel that one just because you don't know what f of 0 and g of 0 are. They don't give it to you. They just give f of 0 and g of 0. So you know that's not true. None of them will go back to that. And then both functions f and g are differentiable at x equals 0. We know that's true because that's the limit definition of the derivative. And if that limit exists, then they are differentiable. So that's true. Both functions f and g are continuous at x equals 0. We know that to be differentiable, the function has to be continuous. So we know that's correct because this one's correct. And then f prime of 0 is less than g prime of 0. We go back and look. F prime of 0, 5 is less than 7. So that one's also correct. So is everyone good on that one?
So I understand like that whole thing with the derivative with the limits, but the only reason I got this one wrong was because I swear when he said is that you can't assume that it is what is the word, continuous, and that unless it was explicitly stated. Like I looked back on one of his PowerPoints and it was like even an example he gave us. So it was like I didn't like choose those 3 answers because like I couldn't assume that was continuous, so then I can't say that it's differentiable and thus those are correct. I don't know. It was like because it was like it confused me because it was like one example he gave like a while ago.
Yeah, I think I know which one you're talking about. Let me look to see if we can find that one. Was it on a quiz or a test?
I think it was on a quiz or a test. I'm not sure.
One of these.
Yeah, I think it was that one.
Yeah. Let's see. F of x and g of x be functions such that
See, I look at that and then I look at the quiz, and it's basically a similar principle. So unless I'm reading into it wrong.
I think the problem is that you don't know if these terms are f of 2 and you don't know if this one's g of 2. So you don't know if that is the limit definition of the derivative. If it if the question explicitly stated that f of 2 equals 5 and g of 2 equals -1, then you would know that that's the limit, that these are the limit definition of the derivative, and then you could say that they are differentiable and thus they're continuous.
Oh, okay.
But since we don't really know what these terms are, we can't say anything about them.
Okay, so it's just yeah, okay, I understand.
So unless you know that, what was it? Like if this said f of x, if the top term was this, you could say that 1 is the derivative of f of x.
But because it's just a value and not necessarily f of 2, you can't, okay. Yeah, I understand.
Okay,
I was
cool.
just confused by that.
Yeah, that example really stumped me, so I really had to go through it. Okay. For the next one, this one was kind of difficult. Okay, let's go through this one. Okay, given the following piecewise function, find non-zero values of a and b such that the function is differentiable everywhere. And then we are given f of x. So I'm gonna just go down here. X, 2, what is it? E to the ax plus b for x greater than or equal to 0, and then a x plus b squared for x is less than 0. All right, this one was pretty difficult. It took me a little while. So for the function to be differentiable everywhere, we know that, let's see, we know it has to be continuous everywhere, because to be differentiable, it must be continuous. So be continuous. And to be continuous, the limit from the right
Has to equal the limit from the left, right?
Yeah. Has to equal the limit from the left. And 0 is the point that we're looking at. So it's 0 from the right and the left. So first we need to ensure that the function is continuous. So what you're going to do, you're going to take the limit, set the limit from the left equal to the limit from the right. So we know that this is from the left and this is from the right. No, other way, right? No.
X is less than 0, x is great. Yeah, it's the opposite.
Yeah, okay, sorry.
I mean, it doesn't really matter, I think.
Yeah. All right, so that's the right and that's the left. So the limit, let me just double check. I don't know why I'm brain farting right now. Yeah, okay. So the limit of e to the ax plus b, so that's the limit as x approaches 0 from the right, that must equal the limit of a parentheses x plus b all squared, and that's going to be the limit from the left. All right, and then what you do after this, you're going to plug 0 in to the limits, because does everyone remember like the limit properties? Like you can just kind of plug in the x value into the function and it equals. So like if the limit of x squared plus 2, that's going to be equal to 0 squared plus 2, which equals 2. So that's that property. All right, so we plug in 0. This is equal to e to the a times 0 plus b. That's going to equal a times 0 plus b squared. And then we just simplify. So we know that e to the 0 is 1 plus b. That equals a times 0 plus b squared is just going to be ab squared. And then what did I do? I believe I subtracted 1 from both sides and then divided by b squared. So we're going to have b is equal to ab. No, is that what I did? Hold on, let me look. Nope, wrong one. Yeah, okay, that's what I did. B is equal to AB, no, B plus 1. No, sorry, I'm dumb. So 1 plus B, I divided by B squared. Divided by B squared is going to equal A. Yeah, that's right. Okay. So we're going to remember that, but set it aside for now. And then what you need to do is set the derivatives of the functions from the left and from the right equal to each other. So I remember he did some complicated, like he wrote out the limit definition of the derivative for like a past example or something. But if you know that the derivatives have to be equal, you can just kind of use the rules that we learned to make a shortcut. So we need to set the derivative of e to the ax plus b, e to the ax plus b equal to the derivative of a times x plus b squared. And then you just take the derivative of each side. So e to the ax, the derivative of e to the ax is going to be e to the ax because it's like kind of itself. And then you multiply by the derivative of ax because it's chain rule, which is just going to be a because you take the x out. And then b is a constant, so the derivative of b is just going to be equal to 0. Set that equal to the derivative from the left. So this is going to be chain rule again. So you're going to get 2a, and a is a constant, so it just stays there, times x plus b, and then the derivative of the inside, x plus b, is just going to equal 1 plus 0. And then simplify, we're going to get a e to the ax equals, let's see, just 2a to the x plus b. And if I make a mistake, please just tell me because sometimes I'm stupid. It's okay. All right. And then at this point, we want to plug in x equals 0. So at x equals 0, once you found the derivative of everything, you plug in x equals 0 just to be able to find the constants. So we have a times e to the a times 0 is equal to 2a times 0 plus b. And we know that a times 0 is 0, e to the 0 is 1. So on the left, we're just going to have a. And then on the right, we'll have 2ab. 2ab. Now, what I did, I divided by 2a on both sides to isolate b. So divided by 2a, that cancels out. The a cancels out on this side. So we're left with 1/2 is equal to b. So now that we have the b value, we can plug that in to this to get A. So we know that 1/2, B equals 1/2, and A equals, what was it? 1 plus B over B squared. 1 plus B over B squared. Plug in 1/2. 1 plus 1/2 over 1/2 squared is 1/4. We can change this to, let's see. And then we're gonna simplify that. 1 plus 1/2 is 3/2. I'm really smart. 3/2, and then keep change, flip. 4 over 1. And then we can cancel out 2 and then reduce. That equals 6. So we know that A is equal to 6 and that B is equal to 1/2. So looking at the answer choices, let's keep in mind A equals 6, B equals 1/2. They're asking you to multiply A and B. So obviously 6 times 1/2 is equal to 3. AB is equal to 3. And then you look at the answer choices and it's this one right here. All good?
Yep, that helped a lot. Thank you.
Cool, cool. All right, on to the next one. 3. The population in thousands of Awesomeville is modeled by the function P of T equals that, where T is measured in years and P of 0 is the current population in thousands. So we know P of 0 is equal to 2020, just because Professor likes to do that. And then P prime of 5 is equal to 0.115 about. So this one, you kind of just need to know how to interpret what a derivative is. So if we know that a derivative, so P prime of X is equal to like P prime of X is equal to the slope of the tangent line. It's kind of weird to explain this. The slope of the tangent line. So it's going to be, let's see, if this is our graph and let's say it looks like that. We're looking at year, was it 2025? Yeah. We're looking for the slope of the tangent line right at X equals or T equals 25. So how much the population changed within the year 2025. And it gives you P of 5 equals 0.115. So let's see. During the year 2025, we're given that the derivative equals 0.115. So put that right here just so we don't forget that. The population changed by, and then we just kind of multiply this by 1,000 because it says in thousands. So 0.115 times 1,000. And then if you multiply that out, what is that? 115, which equals 115 people. I know that one's like weird to explain. You just kind of have to like practice with applications like that to interpret the derivative. Like, does everyone get that?
Yeah.
Okay.
I should have got this one right. I literally just clicked on the wrong one.
Oh, I get that. All right. So
I unfortunately got this one wrong because I thought it was, because even though it said thousands, I didn't know why, I just thought of percent. Even though the 100 one was definitely the only one that should have been right.
yeah, sometimes it's just like mistakes like that. I still make mistakes like 3 plus 2 equals 6. So just recheck your work and make sure you know what's up. Okay. Question 4. Did everyone get this one? No. I forgot what I did for this one.
I didn't have time for this one.
Yeah, this one was kind of crazy. All right, let's see. Assume the function is differentiable at that. And since it's differentiable, we know it's continuous. Defined by the equation of that, whatever that is. So we're trying to find the slope of the line tangent to the curve. So we're just trying to find the derivative of the function at the point -1, 1. So with this, you just have to implicitly differentiate. So we have f of, what is it, x squared plus y squared squared. X squared plus y squared. Is that one squared? Nope, the whole thing is squared. Whole thing is squared. Is equal to x plus y. Equal to x plus y. Then we're going to find the derivative of both sides. Implicitly differentiate. So there's a lot of chain rule going on the left. So we've got 2 times f of x squared plus y squared. No, hold on. Oh my gosh, this is insane. Sorry, let me rewrite this. So it's going to be f of x squared plus y squared. All of it's squared. It's equal to x plus y. Correct? Correct. All right, now for the derivative. It's going to be 2f of x squared plus y squared times, and then we do our chain rule. So now we're looking at this part here. We're going to have f prime of x squared plus y squared. And then now we're going to look at just this part here times 2x plus 2y dy dx, because we're finding the derivative in terms of x. So we have to implicitly differentiate y. And then that is going to equal, the derivative of x is just 1. And then the derivative of y is going to be 1 times dy dx. All right, what did I do after this? And now I believe you plug in, hold on. Nope, wrong one. You found the derivative? Okay. And then after this, you're going to want to plug in the values here that they give you. Into this function here so that you can isolate dy dx. All right, let's do this. So 2, it's going to be at -1, 1, I believe. -1, 1. Okay. So 2 times f of -1 squared plus 1 squared times f prime of -1 squared plus 1 squared times 2 times, wait, hold on, let me put parentheses around this. Nope, go back. Times 2 times -1 plus 2 times 1 dy dx is going to equal 1 plus dy dx. That does not change. All right, and then just keep going until you can simplify. So 2f of, so -1 squared is 1, 1 squared is 1, so 1 plus 1 equals 2. F of 2 times f prime is going to be the same thing, f prime of 2 times, what is this, -2 plus 2 dy dx, -2 plus 2, I believe that's it, yeah, plus 2 dy dx. And that's going to equal 1 plus dy dx. That doesn't change. All right, simplifying this even more, we're going to have 2 times f of 2 is equal to 3. So 6 right here. Times f prime of 2 is going to be equal to 5. Times, we've got -2 plus 2 dy dx. We can't really change that at the moment. And then that's just equal to 1 plus dy dx. And then at this point, you're going to have to isolate dy dx because that's the slope of the tangent line. So what I did, I just distributed this to each, what's it called, term. So that's just going to be 30 times -2 is -60. -60 plus 30 times 2 is just 60 dy dx. And that's going to be equal to 1 plus dy dx. Then move all the terms with dy dx to one side. So I'm going to subtract this and then add this to the other side. So we've got 60 dy dx minus 1 dy dx is equal to 1 plus 60. And then just simplifying that, we have 59 dy dx is equal to 61. And then to completely isolate dy dx, you just divide both sides by 59. And you get 61 over 59. And I forgot what that equals.
It's 1.034.
Thank you. 1.034. Go with that. So it's going to be equal to that, about. Then we go back up. Dy dx is about equal to 1.034. And then we'll know that this is the answer. Cool beans? Cool.
Can I do
All
the
right.
work real quick?
Yeah.
Like towards the end. Thank you.
Cool. All right, for question 5. This is the one that was confusing, right? To everyone. This one took me a little while. Let's see. Okay, the functions f and g are differentiable, thus continuous. And when I read problems, I like to highlight them and just can take notes on what I know is true or not. And sometimes it's not really relevant, but it's still good to keep those things in mind. The table below gives some values of all that stuff. Find h prime of 2 if h of x equals that stuff. Alrighty. So here we know we're gonna have to do logarithmic differentiation. So let's see, h of x equals f of x squared, all to the g of x plus 1. x plus 1. All right, and if you're able to, when there's like a complicated problem, I like to like solve each part in a different color so I don't get too confused. So if you're able to do that, I would try to do that. Okay, so to get g of x plus 1 down, we need to take the natural log of both sides. So ln of h of x is going to be equal to, if we take the natural log, we know we can move that down. So it's going to be g of x plus 1 times ln of f of x squared. I believe. Yes. All right. So then we take the derivative of both sides and we get h prime of x over h of x. And then the derivative of ln x is just one that you need to memorize. And then we have, okay, so we have both of these functions. We're going to have to do the product rule on it because there's x in both terms. So we've got the derivative of the first term. This is chain rule. G prime of x plus 1 times the derivative of the inside is just going to equal 1. And then multiply that by ln of f of x squared. Quick question. Has everyone taken calc before, or this is their first time taking calc?
I've taken calc.
My first time.
Okay. First time. So if you ever need me to just like slow down and kind of explain like the product or quotient rule or anything like that, please just like let me know.
Got you.
Cool. And then we're on that term. And then we have to take plus the derivative of ln of f of x squared. So let's see. We're going to have to take the derivative of f of x squared over just f of x squared because the dx of ln x is equal to, actually I'll say ln of a, just a term, just a function, no, of f of x is going to be equal to f prime of x over f of x. So we're just using that. So the derivative of f of x squared, we're going to have to use the chain rule again. So we're going to have f prime of x squared times 2x, because the derivative of x squared is 2x, all over f of x squared. Let me just erase that. So that's going to be the derivative of ln of f of x squared, and then we multiply that by the first term, g of x plus 1, times g of x plus 1. And then, let's see. Yes, I believe that's it. All right, and then to isolate h prime of x, we're going to have to multiply by the original function. So h prime of x is equal to the original function, f of x squared, oh, it's right there, is equal to f of x squared to the g of x plus 1 times, and then this is addition, so we're going to have to put the parentheses just to make sure we don't miss any term. So we're going to have g prime of x plus 1 times ln of f of x squared plus f prime of x, or we'll put the 2x in front. 2x f prime of x squared over f of x squared times g of x plus 1. All right, and now that we've got h prime of x isolated, we can start plugging in the values that they give us. So we want to find h prime of 2. H prime of 2, we're looking for where x equals 2. So we've got f of 2 squared, which is 4, f of 4, to the g of 2 plus 1, that's 3. And then we have g prime of 2 plus 1 equals 3 times ln of f of 2 squared equals 4 plus 2 times 2 equals 4. F prime of 2 squared equals 4 over f of 2 squared is equal to 4. There's a lot of 2's and 4's in this, and it kind of got confusing, but just have to be diligent about that, I guess. Times g of 2 plus 1 equals 3. And then we can start looking at the table. H prime of 2 equal to f of 4. So we've got f of 4. I wonder if I can just like screenshot this and move it down so I don't. Yay, okay. We can just put that right here. Cool beans. All right, so f of 4 is going to be equal to 3. 3 to the g of 3 is equal to 2. So 3 squared times g prime of 3 is equal to 5 times ln of f of 4. F of 4 is equal to 3, so 5 ln of 3 plus 2 times 2 equals 4 times f prime of 4. Excuse me. F prime of 4 is going to be equal to 1/2 over f of 4, which equals 3 times g of 3. I forgot what that was. G of 3 equals 2 times 2. Oh. All right, and then you just reduce. So we've got 9 times 5 ln of 3. You can't really reduce that anymore. Ln of 3 plus 4 times 1/2 is 2. And then we've got another 2. So 4. That's going to be 4 over 3. All. And then you just distribute the 9. So the final answer is going to be, distribute the 9, 45. This is equal to 45 ln of 3 plus, what is that, 12? Plus 12. And I believe that's the answer. Yeah, right here. So if anyone needs to take like a screenshot of this work or like has any questions, just let me know. Are we all good? Can we move on? Or just need another second? Good. Okay. Whew. One more. We're almost done. All right. So let's see. The tank, or a tank, has the shape of an inverted circular cone with a height of 10 feet. So h equals 10, and a radius of 5 feet. R equals 5. Water is being poured into the tank at a constant rate of 2 cubic feet per minute. So we know dV dt is equal to 2 cubic feet per minute. How fast is the water level rising when the tank is filled to half of its height? All right, water level rising, tank half of its height. All right, so we're asked to find dH dt when h equals 5, because that's 1/2 of 10. All right, and then what I like to do, even though I've like written everything down here, I just put it in one place at the bottom. So we've got the formula is equal to, or V equals 1/3, is it pi r squared h? Pi r squared h, we know. And then I just write down like what we already know. So we know that dV dt is equal to 2 cubic feet per minute. And do pay attention to if that's positive or negative, because if it was like draining at 2 cubic feet per minute, it'd be negative. And then we know that h is 10, or like the height of the overall cone. Overall, h is 10 and r is 5. And we're asked to find dH dt when h equals 5. All right. So since it's a cone, we know, and we're asked to find dH dt, we need to isolate dH dt, but at the same time, since it's a cone, the radius also changes, so we have to take that into account as well. But you can't like derive an equation with like multiple factors unless it's the derivatives are specifically given to you. So we're gonna have to find a way to rewrite this equation so that it's just in terms of h, because that's what we're looking for. So we know that h equals 10 and r equals 5. So we know that r is 1/2 of h, so h equals 2r. And then let's see, we're gonna have to keep that in mind for later. No, nope, sorry, we don't need that. R equals 1/2 h, and then we plug that in. All right, let's rewrite the volume. Volume equals 1/3 pi, and then we know that r is 1/2 h, so we plug that in. 1/2 h squared times h again, and then just simplifying. So this term right here, 1/2 squared is 1/4, h squared is h squared. And then what I like to do, I take this and just, of course I need to simplify it with the 1/3. So 1/3 times 1/4 is 1/12. Got 1/12 pi h cubed, I believe. 1/12 pi h cubed. And then at this point, since we have the entire equation, like we have one factor, one variable, then we can start deriving it. So let's see. dV dt is equal to, we take the 3 and multiply it over here. 3 times 1/12. You know what, I'm going to do pi over 12, just to simplify it a bit, times h squared. And then simplifying this, we can reduce this to 4. This is equal to pi over 4 h squared. And then plugging in the information that we know from up here.
I think you're missing the dHdt.
Oh, haha. Thank you. I stupid. It's okay. dHdt, that's what we're trying to find. Thank you. Let's see. So now that we actually have what we need to find, haha, we can plug in what we already know. So dv dt equals 2. And we're going to set that equal to, it's pi over 4 h squared. And this is when h is equal to 5. So 5 squared dh dt. And then we're just going to rework this to isolate dh dt. So dh dt 2 is equal to 25 pi over 4. 25 pi over 4 dh dt. And then dh dt is going to be equal to 2 over 25 pi over 4, which we can also rewrite as 2 times 4 over 25 pi. So that's going to be